So let's take a look at the experiment we're going to run today. It's a pretty simple experiment. What we've got is we've got a punching bag. And what I've done is I've built a small device out of an Arduino kit. Arduino is a really hackable, programmable interface for electronics work. Really easy to get into, really easy to get a hold of. You can get a lot of the stuff, the starter stuff at Radio Shack and different places like that. It uses a very simple breadboard. Really not the point. The idea is what I've done is I've got this nice little programmable interface, and what I've done is I've attached an accelerometer to it. And what this accelerometer does is it tells us what the acceleration is of the device itself. We mentioned last month that measuring acceleration is really hard unless you've got a specialized tool. Well, guess what? We've got a specialized tool now. So what we're going to do is we're going to let our volunteer here, who happens to be Asher, punch the punching bag with this device attached, and it's going to tell us how much acceleration he causes the punching bag to undergo. But remember, that's only part of calculating the force. We still need the mass. So we've also weighed the punching bag so we know what its mass is. And we'll talk about that in just a little bit when we actually get to the calculations. I do want to defend Asher's honor here a little bit. He's pulling his punch quite a bit because we ran some test runs of this earlier, and he totally annihilated the punching bag and knocked it over and took all of my electronics with it and just about did a lot of expensive damage. So we've asked him to pull his punch, so he's throwing about a half punch here. But still good for what we're doing and really shows you how you can very simply apply and measure force in everyday life. Okay, so we've gone through, we've done our experiment, we've got a lot of data. So let's take a look at that data and start putting it together. What I've done is, I've done what you should do whenever you're doing any type of experiment, is I've basically put together a very simple table of everything I know and everything I want to know. I've also created columns for converting between units, because a lot of the units we're going to get out of our experiment are in British units. We don't really use British units a lot in more traditional science. We prefer to use metric units. They're a little easier to work with, and we'll talk a little bit more about that during the advanced section. So first, the mass of the bag. We did a quick measurement on how much the bag weighs. It turns out it's a pretty heavy bag. It weighs about 17 pounds. Now, we can make it a lot heavier if we want to, but we didn't fill it up with water, which makes it a lot more stable. We convert that over to metric, and we get 7.7 kilograms. Easy to convert to metric. It's a very simple multiplication to go from British pounds to metric kilograms. I'm going to be honest, I just went to Google and asked it to do it for me. So our measurement, if you were paying attention to the screenshot we had below, you saw that 1.77 Gs was the amount of acceleration that Asher was exerting on that punching bag. If we convert that G into full metric, remember 1 G, or the force of gravity, is 9.8 meters per second squared. So if I just take 9.8 meters per second squared, multiply it by 1.77, I get 17.3 meters per second squared. So that's our acceleration. And so we know that to get force, all we have to do is multiply the mass times acceleration, and poof, 133.21 newtons. Not bad. To put that in context, it's a decent amount of force. It's enough to break a bone if you were in the right position. It's not so much that you could really do some truly serious damage to someone, but it's a good enough punch. You wouldn't want to get hit by it. It's interesting. We did the experiment a couple different times just to get the calibrations right, and when Asher actually did let loose, the amount of force that's put out is actually pretty shocking. So it's just something to keep in mind. Is it may not look like much when you're putting out force, but it's really interesting if you get a chance to measure these things. Even the simplest actions can really put out just a ton of actual force. So that's basically what we want to cover for Science Club. We're going to move on to the advanced content. If you're not sticking around for the advanced content, you can go ahead, shut off now, no hard feelings, and we'll see you next month for Science Club in the October session. Advanced material. We're going to go through these pretty quickly. Very simple advanced material this time. First off, vectors. So as we typically do in Science Club, we've taken a couple of things and we've simplified them to make them simpler. Generally, when you measure something in physics, you're measuring across multiple dimensions. What do I mean by that? Well, I mean, you're looking at if you're looking at space, looking at something in front of you. Let's take a ball that you put in front of you. You drop that ball. Well, the ball goes down. Great. It went, and that's one dimension, up and down. If I throw the ball, it goes out and it goes up and down. So it goes from my hand, which is presumably in the air, all the way to the ground, so down. But it also went outward, so it had some distance from me. Now, if I threw it, if somebody else threw a ball who was standing off to my side, our two balls might cross over each other. So there was the distance from me, and then there's this other dimension. So in other words, an x, y, and z dimension for those of you who've gotten through a level of algebra where you're looking at three-dimensional algebra, or even better yet, some geometry. Each of those dimensions, x, y, and z, so x, the distance from me to any given point, y, some degree of width, and then z, looking up and down, or a vertical axis. Really, each one of those is a separate measurement, and the value of that measurement is referred to as the magnitude. So here's where we made things simpler. We only measured one dimension of the acceleration that was exerted on the punching bag. We measured the x. If you go back and you look at the video, you'll see where my output actually says the acceleration on the x-axis as opposed to the acceleration on the y-axis, because I was measuring it on two different axes. That was fine because, as it turns out, if you go look at the video, the acceleration on both axes was about the same, and that's because it's a very centered object and it's not going to tilt over a whole heck of a lot. Works to our advantage, but it's something to keep in mind. When you're doing physics, you need to look at all the different dimensions that are impacted. It's not enough just to look at the simplest one, the one that's right in front of you. You need to look at all of them. There are some experiments that truly are simple. They're truly one-dimensional. We refer to those measurements as scalar measurements, and we adore those whenever they come up because they're really easy to work with. But keep that in mind. You're looking at multiple dimensions, and we put all those different dimensions into a single object we call a vector. Okay, so throughout today's session, I've referred to British units, sometimes English units, and metric units. When we're doing taking measurements, what we do is we choose what units we're working with. One of the things we talked about in last month's Science Club is how important it is to know what unit you're measuring in and to make sure you keep that unit information with your calculations throughout every step of the process. The reason being, most people's mistakes stem from, at this level of physics, stem from just not keeping up with their units. So it is important to talk about these units a little bit and understand them better. When we're dealing with a lot of the things we talked about today, we were dealing with British units. You use them all the time in the United States. You use pounds, inches, all of those are what we call British units or sometimes English units, depending on which specific standard you're using. The problem with pound when we're dealing with force is pound sometimes refers to mass and sometimes it refers to force. In more advanced usage, you'll see people say pounds mass or pounds force. Really important to make those distinctions. Generally, that's one reason we try to avoid using British and English units in basic physics work, because that confusion, we don't need that. That gets in our way. It slows things down. They're also a little more difficult to manipulate numerically. They use to go from inches to feet is, it's 12 inches to a foot. Well, that doesn't always make a whole heck of a lot of sense to you if you think about it. Why 12? Well, it turns out there are old historical reasons for doing that sort of thing, as opposed to the metric system, where everything is based on base 10, which is the basis we use for our numeric system altogether, as you know from your basic math work. So metric system's just easier to work with in that regard, and you'll see metric used nearly throughout most of your physics work in school, and most of your science work in school, period, actually, in all reality. The one difference that's worth noting here is in the US, for some reason, the automotive and the mechanical industries use a lot of British units. You'll see references to foot-pounds of force and all sorts of other really weird units that you may not hear of. It's worth becoming familiar with them, looking at what a pound really is and what it means, what a foot-pound of force is. It's the amount of force needed to move 1 pound, 1 foot. In different units like that. You're going to see those come up quite a bit if you're dealing with automotive stuff or basic mechanics. So worth taking some time just to get familiar with them. I don't recommend doing your work in them, but at the same time, it never hurts to know about them in case you run across them. So that wraps up Science Club for September. We're sorry that we were rained out again, but let's keep in mind that we will be picking up on the third Sunday of October, and should be a really, really good session. We're going to hopefully get a chance to shoot some things off and build our own cannons, and we're going to talk about pressure. It'll be a lot of fun. Look forward to seeing everybody in October. Thanks.